Okay, so welcome everybody. Just to recap, what are our plans for these last two lessons? They will be mainly practical lessons. So I will start by giving to you some background information about conversational agents, and I will show you how you can prototype a conversational agent by using a cloud platform, and then you will work in groups by designing and prototyping your own conversational agent. You will have also 2 hours in the next lesson to continue working on your project, and then in the last 2 hours you will present your work to the class. Okay? So I will be very brief. Let's start with some basic background information about conversational agents. So first of all, what can we do with voice and speech in human AI interaction, and in particular, what is the difference between voice and speech? Is there any difference in your opinion? Are they the same thing or not?
I think not, because voice is just like a sound, whereas
Okay.
speech is a mixture of sound and words that together have some meaning.
Yeah, exactly. Voice is the sound that we can emit, while speech is instead more structured, and it's what I'm doing right now, so with a specific language and with a specific meaning associated to the voice, to my voice. So voice in theory can be an efficient input modality. Through it I can give commands to a device very, very quickly, I think. Speech is instead more ambiguous, mainly because it's strongly linked with the underlying language. And by the way, fully understanding natural language from a computer remains a dream, at least right now. That being said, we have nowadays voice and speech interaction in many different technological devices, on smartphone, with smart assistants like Google Assistant and Siri, but also we have also seen, for example, Alexa. They simulate a natural language interaction, but as we have seen in the last lecture, in the past lectures, there can be sometimes some problems in this kind of interaction, in this kind of tools, because these systems use a restricted set of spoken commands, and the user must learn what are these commands, and the user should also remember these commands in order to interact with this kind of system. Furthermore, you cannot ask everything, obviously, and you also need to learn how to say commands. So maybe you know what is your goal, but you don't know what is the specific command that the tool can understand. And this is something different with respect to traditional graphical user interfaces, where you have, for example, icons. So if there is not an icon, you cannot perform this operation. Here instead, in front of a device like Alexa, especially at the beginning of the interaction, you actually don't know what you can do with this kind of devices. Because typically these kind of devices don't have a screen. Okay. From a computer perspective, voice-based interaction is mainly characterized by 2 steps that are speech recognition, so also called speech-to-text. So this is the process to transform the user speech into text, and the opposite, that is called text-to-speech or speech synthesis. So typically devices like Alexa operates in this way. They get your speech, They translate it to text, they elaborate the text, and then they use speech, text-to-speech to answer to you through speech synthesis. And so voice-based interaction may leverage both speech recognition and synthesis, or only one of it. So in some cases, like in Alexa, there is this part of natural language processing. This is the hard part of this kind of devices. So Alexa is, in theory, able to understand what you are saying, so your speech, the meaning of your speech, in order to provide a response. But this is not always the case. There are also technologies that simply do speech-to-text or text-to-speech, it depends, without any natural language processing. Like, here are two examples, dictation.io, but also Google Translate. In this case, there is no natural language processing, I think. There are clearly some advantages in using this kind of interaction, and we will see them in a moment. And we have already seen some disadvantages of this kind of interaction. You have to learn what you can say. The environment needs to be a good environment, so there shouldn't be so much noise, for example, otherwise the device cannot understand and recognize you. And then there is also another problem that is more linked to our human nature, let's say. And the problem is frustration, because these devices speaks and listen as they were other humans, but they cannot just understand you very well. And so this gives rise to a loop of frustration, because I have to perform several different trials and errors typically with these devices to reach my goal. Okay, the slides summarizes the advantages, or rather the opportunities, around voice-based interaction. So spoken interaction is successful in some cases when users have, for example, physical impairments, when the speaker ends are busy, or when mobility is required, and so on. And this slide instead summarizes the obstacles in voice-based interaction. We already talked about some of them. So some of them are technical, while others are more related to the nature of speech and voice. So for example, besides the obstacles that we have already seen, you can, for example, insert a password vocally. Let me lower down the volume. Okay. And also error correction in this kind of systems is terrible, I would say. Typically, if you make an error, you restart from scratch. Okay, there is no way of recovering easily from an error. And to conclude our background information, this is a summary of the typical phases that are involved in this kind of conversation. So typically there is an initiation phase. For example, you press a button, or in the case of Alexa, you say the wake word, Alexa. Then you need to know what to say, and this is one of the problems, as we have seen before. So the problem of learnability. Then there are probably recognition errors in the speech-to-text, and this kind of error will happen for sure. Correcting errors is somewhat difficult, as I said before, so typically you start from scratch. And then there is this mapping that is typically performed by the conversational agent that map your command to the right action, and this is another complex problem that involves natural language processing. And then there are feedback and dialogues to be sure that the action is right. Okay, now we have seen some background information. Let's explore how this kind of interaction is exploited in AI-based systems. And a very popular example here are conversational agents. So for example, Alexa. So this kind of AI tools typically expose a voice user interface to allow the user to interact with the system through voice or speech commands. Here we put together speech and voice without worrying about the differences, but as I said before, there are some differences. So for example, besides understanding our speech, a conversational assistant may also try to understand our voice. For example, Siri tries to accept commands only from you, and while Alexa do not perform this kind of check. So the primary advantage is that is the possibility of having hands-free during the interaction process, but also it's also useful when you need eyes-free, for example, while you are driving. Okay, and so as I said before, this kind of systems typically offers voice user interfaces. You have probably heard of conversational interfaces instead of voice user interfaces. And what are the differences, if any? So a conversational user interface is a system which mimics a conversation with humans. These conversations are not always perfect, and interaction with this kind of systems can be actually weird. And we still miss a real conversational assistant. So most of the time, conversation is just a question and an answer, stop. But anyway, conversational is something that applies to voice user interfaces, yeah, but also to other kind of interfaces like chatbots, so interaction that happen in text-based interfaces. So conversational user interfaces are not restricted to voice only, but they are about natural language dialogues in general. In most cases, voice and text-based interactions are mixed together, and this is good because mixing voice and screen is often a good idea, because voice is an efficient input modality, while a screen is an efficient output modality. If we focus on voice interaction, in general, we can have different kinds of voice user interfaces: screen first, voice only, and voice first. Any example of a screen first system? Yeah, the smartphone with Siri. Yeah, a smartphone with some assistants. It's a device that is born with a screen, and we have added some voice capabilities with AI. A voice-only device? Yeah, the Echo Dot with Alexa. So it's the Alexa assistant integrated in a physical device. And any examples of a voice-first interface? So it's an interface that uses voice as the primary channel for interacting, but it has also a screen. We have seen an example.
The echo with the screen.
Yeah, there is the echo with the screen, and also Jibo, I think the example that we have seen last time, it's a conversational assistant that also has a screen. Okay, so screen-first devices, as we said, are smartphones, tablets, and so on, and they are nowadays definitely the most common examples of systems that can exploit voice interaction. These devices typically have impressive speech recognition, and they can process language very, very efficiently, but the overall experience is quite different. So we have devices on which voice interaction works well, and others on which it's more difficult. So Siri does things in a way, while Google Assistant does things in another way. And so there is no a uniform layer here. There are also other limitations on these devices that are mainly due to the fact that they have a screen and they actually use the screen for the majority of interactions. So for example, there are some missing functionality. Users can start a task via voice in these devices, but then the next steps require them to use the touch screen. So in the slide, for example, there are two similar examples on Siri and Google Assistant. I can ask them, please find a recipe for some food, and they answer to me, okay, I found something on the web, take a look, but then you need to manually click on a link, and the conversation stops here. And also visual affordances are typically missing in these devices. So Siri, for instance, omits several visual affordances when you are dictating a message, for example. And the result is that you really don't know how you can, for example, edit a message before sending it. And typically you end up by taking the phone and by writing the message with the touch screen. Google Assistant is slightly better in this respect. So in the screenshot here, there are some visual affordances like the button about chocolate. So Google is using the screen to tell you some other actions that you can perform during the interaction. Screen-first devices also make a poor use of the screen space, typically. So sometimes the feeling is that this kind of voice interactive systems have been added to these devices without thinking about what it means to have a voice-based interaction. Here, for example, when sending a message via voice, you have a totally different interface with respect to the normal one. And the information for the user are very limited, no buttons, anything. And another example, if I ask Siri, check my messages, Siri simply answers to me, okay, you have a new message. Okay, now Siri has started. No, it's not the time. The assistant of Apple simply answered to me, okay, you have new messages from, for example, Bob. Okay, thank you, but why you cannot read me the message? So in this case, voice interaction is quite unuseful. Obviously, here there are also some security and privacy problems to be taken into account, but anyway, these kind of situations are actually very common, and you typically end up by picking your smartphone and performing manually the operation. About voice-only devices, as we have seen with Amazon Echo, we don't have any display, and audio is used both for input and output. There are also some lights that can be used as a feedback, for example in Alexa, but yeah, the primary channel is voice. If you don't mix different languages, they have a quite good accuracy in understanding you, in speech recognition. If you start mixing different languages, there are problems, many different problems. Other problems related to this kind of voice-only devices. They are quite prolix in the answers. With a screen, for example, you can easily skip information and find what you are looking for. In the output of a voice-only device, you have to listen to all the answers from the device, and so you cannot skip information easily. And so from a design point of view, you should really try to balance the amount of information that your conversational assistant provides. Then there is the learnability problem. So you have to know what to say. Some operations can be challenging. For example, you can easily set up a timer in Alexa, but then it's more difficult to know how much time is left because simply you don't have any screen. Or another example is that getting a weekly forecast is like a memory test because of the problem of before, because you have to listen to all the audio of the response, but maybe you only want some specific parameters. And finally, you cannot simply perform some kind of operations like inserting a password vocally. And finally, we have voice-first devices that can be seen as voice-only devices with a screen. In the slide, for example, there are two examples of an Amazon Echo with a screen. They are designed to be used by voice. The screen may, in some cases, augment the output. Okay, so they rarely provides buttons or menus for input. It's just a way to overcome some limitations that voice-only devices have in communicating the responses. So, for example, I can actually see the timer if I set up the timer, or I can read the text of a song in the first example. From the voice perspective, there are no differences with traditional Amazon Echo, while the graphical user interface is less powerful than the one adopted by screen-first devices. Okay, we have seen the three kinds of voice user interfaces. Now, how can we design them? So, or more in general, how can we design a conversational assistant? So let's move from the point of view of the user to the point of view of the designer. Just to recap, voice interaction may be challenging because you have to learn what to say. Let's say it's a new language to learn. And this is true for the user, clearly, but also for the designer or the developer, because you have to do some choices, and your choices will influence the interaction between the user and your system. Such a learning process typically happens through immersion, so by means of trials and sometimes errors, or through suggestions, like the one presented in the device on the slide. I don't know if you can see it, but this Amazon Echo also displays on the bottom some suggestions about commands that you can use, that you can explore to interact with the device. So it's a good idea to provide user with a sort of immersion, trying to teach what are the available commands that the user can use. But there is a big attention point here, that is, people often have unrealistic expectations, especially for devices that exploit voice interaction. So users often think that a conversational agent is a natural conversation partner, while it is not, clearly. So they start talking with these systems freely, like speaking to another person, and obviously these systems are not able to process this kind of input, and so users get frustrated much more than with a traditional graphical user interface, because they have high expectations. So this is a point to take into account, and actually it's a point that is addressed by all the guidelines on human AI interaction, like the ones that we have seen last time. So people have unrealistic expectations, and we should therefore make clear what our agent is able to do. so to delineate the boundaries of our conversational agent. So to design this kind of interfaces, we can establish a process in which the first phase is to get a clear picture of who are our users and what are their needs. So what they will communicate, what they will ask, and so on. And according to this big picture, you can start to select, for example, the language, the available commands, and the words, the language that are needed to communicate these commands. Then you can start writing some sample dialogues and maybe sketch a diagram of the conversational flow. This is important to design the flow that the user will actually experience, and also to delineate the capability of the system. And in this phase, you can also conduct some experiments, even without a running tool, to understand which dialogues are better or more effective. So obviously, in the exercise, you're not required to do that. But during this phase, you can also compare different strategies, different ways of instaurating dialogues to see which strategies are more effective, without having to write one line of code. In general, during these phases, the focus should be on the spoken conversation and not on any visual elements. So the suggestion is try to think about a voice-only interface. And to design a conversational assistant, we can also try to link the conversational frames that we typically employ in our normal conversations. So we can analyze these phases, because we can have these phases also with a conversational agent. So we can start a conversation with a conversational agent for controlling something by specifying a goal and sometimes a way to achieve the goal, like play radio DJ with tune ID. Close to this example, we can delegate something to ask for an outcome without specifying how to achieve it, like play radio DJ or play some jazz music. And these first two kinds of conversational flows are basically those that are adopted by contemporary conversational agents. So we can, typically with devices like Alexa, we can control and delegate. In theory, we could also implement some guiding conversational flows to allow users to discuss with the agent how a goal can be achieved. For example, I want to hear some music, how should I do it? This would be particularly useful for novice users that still don't have a clear mental model of the system and don't know what commands they can use. And then there is collaboration, through which you mutually decide a goal. It's instead more difficult to be implemented in a conversational assistant, of course. Okay. As we are learning in the last lesson, the suggestion is always to try to apply established guidelines on human-AI interaction. There exist very specific guidelines that apply to voice user interfaces, but the guidelines by Microsoft apply as well, because they are quite general. So in the exercise, the suggestion is try to use them, and also the tool that we have seen last time. Okay. Now it's time to start thinking about the practical part of this lesson and the next one. So we will try to design and implement a conversational assistant. So let's try to understand how we can do this kind of task. I will show you a very simple example of a conversational assistant for getting weather forecast. It's a quite simple example, so I will not focus too much on the design part of this example, but I would like to show you how you can practically prototype, create a conversational assistant through a cloud platform that will give you some AI capability for the natural language processing part. So we're going to exploit these platforms that have some kind of natural language processing. They are typically cloud-based, and they allow you to design and integrate voice user interfaces into mobile apps, web applications, devices, and so on. These platforms focus on simplicity and abstraction, so you don't need to write any code typically, because also the natural language processing part is already implemented, so you can simply use it. So they are quite simple to use. It's just a matter of configuration. Do you have any familiarity with this kind of platforms? Okay. So I would say that there are basically two main categories of conversational platforms. You can have some extension of a product. So examples are actions on Google or the skills for Amazon Alexa. So something that need an existing product, be it hardware or software, to work. So you can develop a specific feature, for example, an Amazon skill, to, let's say, improve and extend the capabilities of an existing device like an Amazon Echo Dot. Then there are standalone services that can allow you to create a wide range of conversational interfaces in one platform, in one single platform. And by definition, the systems that you can develop with these standalone services are more general than the extensions of a product and can be easily used by different products. So the same conversational agent that you develop with this kind of platforms can be integrated with Alexa, for example, but also on my smartphone, in a mobile app, on a web application, and so on. I've reported here some examples like Dialogflow, IBM Watson, and so on. I don't know if you know them, but anyway, I will show you how to use Dialogflow. But they work more or less in the same way, at least from a developer perspective. So let's dig into Dialogflow. It was founded in California and acquired by Google. It was free up to last year, I think. And then Google decided to have two different versions of the same platform. One that is the essential version, that is free, and the other one that is more complex and it's not free. We will use the essential version that is sufficient for our exercise. In Dialogflow, you can have a one-click integration with different services, from Telegram bots to Facebook and Google Assistant. Another nice thing is that you can have support for multiple languages, and there are REST APIs, and there are various official SDKs for several different programming languages. So to introduce Dialogflow, I prefer to show you a simple example that we have prepared. So you can find the link of a GitHub repository on the website, but also on the slides. Okay, let me mirror the display. Okay. So this is the repository. I simply download it. So as you can see in the folder, there is a zip file that is the conversational agent that we have exported from Dialogflow. And then there is a simple web application developed in Python that has a very simple website I will show you later to interact with the conversational agent. It's a chat-based interface. But let's start with the conversational agent. So, okay, this was the website. Let's start with the conversational agent. So, this is Dialogflow, so dialogflow.cloud.google.com. Let me zoom the page. No. Okay. I have already another conversational agent, but let's create a new conversational agent. So here I can create a new agent. Okay. I can give a name to the agent. Let's call it example. Class example, it's the same. Create. Okay, the default language is English. I can also select a time zone, but let's. Okay, after a while, Dialogflow should create the agent. Okay. So obviously, now the agent is empty. You can start implementing it. But to show you the example, I will just import the example that you can download from the repository. So I can go on the settings of the agent that I've just created, export and import, and I can import a zip. Okay? And I drag and drop the weather agent, and I need to write import. Okay. Okay, the agent has been imported, and we can now explore it, just to see the main concepts in Dialogflow. So there are two main concepts here, intents and entities. Let's start with intents. Okay? As you can see, there are three intents in this example. What is an intent? It's just a portion of a dialogue. Okay? So a question from the user and the answer from the system. This is an intent. Question and answer. If you need some dialogue, some multi-step dialogue, you have to obviously implement, design multiple intents. Okay? Let's start with the easiest intents that are automatically created by Dialogflow. Also in a new agent, Dialogflow automatically creates the default fallback intent and the default welcome intent. For example, the default welcome intent is the intent that is mapped at the beginning of the conversation, okay, to say welcome to the user. Okay, as you can see, in an intent there are two different sections. One is the training phrases, okay, that are the phrases that can be used by the user to invoke this specific intent. In Dialogflow, you can manually add some training phrases, and then Dialogflow will use these phrases to train the machine learning algorithm that is the natural language processing part of Dialogflow. So as you can see, there are already some training phrases here, but you can add your own here. For example, I don't know, hello bot, and so on. Okay? So Dialogflow will use these phrases to train the machine learning algorithm. So I don't have to use one of these specific sentences, but I can also mix the words, and Dialogflow is able to successfully map the intent. And then there are responses, okay? So what the bot will say when this specific intent is linked. In this case, there are a list of, let's say, static responses. And so Dialogflow will select randomly one of these responses that are static to be delivered to the user. Okay? Obviously, this is the simplest case, and responses should also be dynamic in some cases, because some responses will depend on the user answer question. For example, if I ask the assistant, what's the weather like in Turin? Obviously, before answering to the user, I need to query what is the weather forecast for Turin, and then dynamically answer the user with this kind of information. And this is achieved through fulfillment. So if I enable a fulfillment on an intent, I can link the intent to, for example, my own web server. So if there is a fulfillment, Dialogflow will map the intent, will send the request, for example, to my server. In my server, I can perform a request to an external service, for example, to get the weather forecast for Turin, and then I can send back the response, the dynamic response to Dialogflow that will show the response to the user. Okay? This is what happens when the intents are more complicated and when the responses need to be dynamic. Okay? This is not the case of our exercise. In our exercise, responses will be static. Okay, your bot will always produce the same output, chosen randomly from the responses phrases. But yeah, if you want to develop something more complicated, maybe if you are using this kind of technology in your research, you can obviously develop something more complicated. Okay, besides training phrases and responses, the other key concept here are entities. What is an entity? It's a collection of things. It's something like a variable. Okay? With entities, we can generalize an intent. For example, okay. If I go on the ask whether intent, that is the main intent of this example, I can see that in the training phrases there are some words that are highlighted because they are actually an entity. For example, Turin is a city, obviously, while tomorrow is a date. I can label some word so that Dialogflow can understand that this part of the commands are actually variables. And so in this case, for example, just with these training phrases, I can ask the assistant, for example, tell me the weather in, I don't know, any city in the world. And Dialogflow is able to map my request to this specific intent. Okay, so I can generalize an intent with entities. There are system entities. Cities and dates are system entities that are already provided by Dialogflow, but you can also obviously create your own entities. So if you need a concept that is not modeled by Dialogflow, you can create it. And also, you can, for example, say to Dialogflow that some entities are required. For example, in this case, the city is required. So if I can also design what is the prompt for the user. For example, if I say to this specific conversational assistant, tell me the weather, without specifying the city, Dialogflow will automatically ask me where, okay? Because the city is required. Okay, and you can also use the entity inside the response. For example, in this case, the response is always static, but in the response, I can also put the city that the user has used in the command. So if I ask, then we will try it, but if I ask the conversational assistant, tell me the weather in Rome, it will respond, it will be sunny in Rome, okay? Okay, intents, entities, fulfillment, and then there are integrations. As I said before, you can integrate a Dialogflow assistant with many different services and devices, for example, in Slack, in Telegram, and so on. There is also the web demo. So let's try to integrate. I enable the web demo integration. Okay, it's enabled, and if I open this link, Dialogflow provides me a very simple interface through which I can test the bot. For example, oops, I can write, hello, good day, what can I do for you today? Tell me the weather in Milan, for example. Okay, it will be sunny. You can also use this web demo for your exercise if you want. Otherwise, you can use our own example that is, as I said before, a very simple website developed in Python. If you want to use it, there are some steps that needs to be performed. And the first one is getting a key, an authorization key, let's say, to authorize your client to access your own agent. It's a little bit complicated, but let's see. When you create or import a new Dialogflow project, Google automatically creates for you a Google project that can be accessed in the Google Cloud Console. That is here, console.cloud.google.com. So probably I can select my project if I go in all. Okay, here we are, class example with this strange name. This is the project that Google's automatically created for me. I can select it. And let's do some zoom. I must go in this menu for authorization, and then I need to click on service accounts. I will create a new account for this kind of project. Okay, here we are. Create a service account. I can give a name, it's the same, my client. Create. And I need to add a role for this account to authorize it to use Dialogflow. So if I type Dialogflow here, Dialogflow, okay, I can select Dialogflow API admin. So I'm giving to the service account the admin authorization to use the API of Dialogflow. Continue. Done. Okay, I've created an account, and now I can create a key, an authorization key for such an account. So I go on, I don't remember. Okay, here, actions, manage keys. Okay, add key, create new key. And here, I will download a JSON file that will contain my key and I will put this JSON file in the folder of my website. Okay? Create. Okay, as you can see, there is a JSON file in my download folder, and I put it inside the root folder of my example. Now I open the project, for example, with PyCharm or Visual Studio Code. It's the same. Okay, let's open. Open. Okay, it's a very simple website. It's a web application developed in Python with the Flask framework. I don't know if you know it, but anyway, it's very simple. There is just an index.html page with a chat-based interface. And as you can see, these lines is the one that gets the authorization key to perform the request. So the file is named client secret. So I can rename my file, my JSON file that I've just downloaded, into client secret. Okay, perfect. And then you need also to specify the name of your agent here in this command. I don't remember the name. Let's check it. Okay, class example. Yeah, it's this one. Let me see if I can copy it. Yes. Okay. This strange name here. Okay, when I've specified these two things, so the file with the key and the name of the agent, I can simply run my app.py. I need to select an interpreter. Yes, run. Oh. Here we are. I need to select the Python interpreter, run. Okay, as you can see, this very simple web server is hosting my website on this link. And there is a chat-based interface through which I can interact with the agent. There are also speech-to-text and text-to-speech operations. You cannot hear because there is the microphone, but let's try to remove it. No.
Today.
Okay. For example, what's the weather in Turin?
I didn't get that.
Okay.
Can you repeat?
What's the weather in Rome?
It will be sunny in Rome.
Okay, it is working. Okay, and I can also use the microphone to give the command vocally. Okay. Any questions? So let's see the exercise of today. You can find it on the website, of course. This one. So you will try to design and implement, prototype a conversational agent. It should be vocal and or textual. You can decide. Obviously, you can reuse the example that I just show you, and the answer will be fake, so static. There is no need to implement any fulfillment. So you can read the file, but the first step is to define what is the topic of your conversational assistant. You can also reuse some of the ideas that from your journey maps, okay? And the intelligence here should be mainly in the conversational part. So you should really try to design a good conversational flow by applying the guidelines and the tools that we have seen in these lectures. And you need to write down your idea, the topic. You have to provide some screenshot in a set of slides that you will present next time. Then the step 1 is to design the conversational interface. Yeah, there are some possible questions to be answered. The suggestion is to use, as I said before, the guidelines and also the tool that we have seen last time. And finally, step number 2, you will share the idea and hopefully your prototype with the class, also maybe with a very brief live demo of your prototype. Yeah, we were planning to have 2 different presentations, one before implementing the prototype and the other one at the end, but let's keep one presentation only at the end of the exercise. I think it's better. We don't have so many time. Okay. You need to submit your slides by the end of the week, but yeah, the presentation will be, I think, next week. Any questions? Okay, you can start working in groups. Obviously, if you need help, I can help you. And okay.